Today's video starts on page 15, problem of the day. You're going to answer number 16, 17, and 20 on your own. Pause the video, take a couple minutes, fill those in. Y over x equals k, y equals kx. Answer those questions. Identifying proportional and non-proportional relationships in graphs. Yesterday we did tables, today we're doing graphs. Number 1. Determine whether or not the following graphs represent two quantities that are proportional to each other. Give a reason. Okay, well, we have to know that our y divided by x is always a constant. So I see that the y value of the first one looks like it's about 100, 100. So 100 divided by 100, this point right here, is equal to 1. Then the point 200 divided by 200, that's 1. 300 divided by 300, that's 1. 400, y divided by x divided by 400, that's 1. 500 divided by 500, that's 1. So yes, the graph has a constant rate, right? Yes, the graph has a constant rate. The k equals 1 has a constant rate, and it goes through the point, which we're going to talk about. It goes through the origin, the point 0, 0. Letter B, age versus admission price. The graph doesn't start at 0, 0. So if you're 0 to 6, you always pay $5, which that does happen in the real world. Little kids get in cheaper until they get to a certain age, and then they have to charge more, correct? But this, no, this graph does not start at 0, 0. So it is not a proportional. The graph does not start at 0, 0. And I can see that they're explaining this to me in this box down below here. The graph does not start at the origin, which is called 0, 0. When two proportional quantities are graphed on a coordinate plane, the points lie in a straight line. That's that constant k. They have a constant rate k that passes, so that's the first thing that has to happen, that passes through the origin, 0, 0. That's the second thing that has to happen. So in order for it to be proportional, two things have to be true on a graph. It has to go through the origin, 0, 0, and it has to go at a constant rate of y over x equaling k. So let's see this in some more graphs. You can pick, I don't think this buy. You can pick your own strawberries at Rivers Ramblin' Farm for $2 per pound. You can pick your own strawberries at Cole's Colossal Farm for $1 per pound, but you have to pay $5 up front container to collect the strawberries in. Use the following equation for each of the farms. Rivers Ramblin' Farm is y equals 2x. Cole's Colossal Farm is y equals x plus 5. Create a table for each farm for x pounds from 0 to 6. So I'm filling in Mr. Rivers first, because his is easy. Y equals 2x. Well, 2 times 0, 0. 2 times 1 would be 2. 2 times 2 would be 4. 2 times 3 would be 6. 2 times 4 would be 8. 2 times 5 would be 10. And 2 times 6 would be 12. Cole's Colossal Farm, y equals x plus 5. So he would be 0, 1, 2, 3. These are the pounds. 4, 5, 6. So cost Cost is the dependent variable. It depends on how many pounds. That's the independent variable. So yes, cost is the y. So x plus 5. 0 plus 5 would be 5. 1 plus 5 would be 6. 2 plus 5 is 7. 3 plus 5 is 8. 4 plus 5 is 9. 5 plus 5 is 10. And 6 plus 5 would be 11. Graph the cost of strawberries for each farm below. Okay, I'm going to put pounds on the x-axis because that's the independent variable. And I want to use the majority of my graph paper, so I'm going to count every 2 units over. 5, and yes, it will fit. So pounds is my x-axis, right? And my y-axis is my dollars, or cost, which is in dollars. Not euros, not pesetas, or pesos, it's dollars, so dollar symbol. And I'm going to use the green marker for Cole. I'm going to do him first. Oh, got to give a title to my graph. Title. So the title would be cost of strawberries. So my points for Mr. Cole. Oh, I got to put my dollars on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I don't think anybody went above. Oh, Mr. Rivers was 12. Okay, so we're good. We're going to put them, they'll fit. So Mr. Cole starts at 0, 5, 1, 6, 2, 7, 3, 8, 4, 9, 5, 10, and 6, 11. So that's Mr. Cole. And yes, I'm going to use a straight edge and connect these points. So here's Mr. Cole. And Mr. Rivers, I was using the blue marker, so I'm going to use the blue marker there. His points are 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. Oh, they both have 5, 10. And 6, 12. So Mr. Rivers in the blue there, again using a straight edge, I'm going to connect his points. So I have this ruler tool on my graphing smartboard. Oh, that's off. I counted over 1. Yes, I counted over 1 too much. There's that point right there. Because this 6 and that point are not there. This is 6. Okay. So this point and this point. Okay. Now I got it. So I can see that Mr. Rivers is going up faster. And let's answer some questions here. Which farm is using a direct proportion? Explain how you know using the tables. Explain how you know using the graph. Well, Mr. Rivers' farm is a direct proportion. It starts at 0, 0. So I'm talking about the graph first. Got to have those two things. 0, 0, and is a straight line because it has that constant rate. So it's got both parts for the graph, and the table, Rivers has a constant rate to fill in that table, right? Y equals kx. In the table, $2 per pound. So Rivers is the direct proportion relationship. Both graphs have x equals 5 and y equals 10, or the 0.5, 10. Why is only one of them a direct proportion? Well, because Cole's starts at $5 and then adds $1 a pound. So both farms charge $10 for 5 pounds. And we'll talk about this more in class tomorrow. That's it for today's video.